Hello, this is Dr. Lori. Welcome to this discussion on pictures and numbers. I like calling this pictures and numbers because people aren't scared of pictures and numbers like they are scared of graphs and descriptive statistics. So we'll just call this pictures and numbers. So to begin with, I'd like for you to do an exercise, a mental exercise while I'm talking. I want you to pay attention to these two graphs on the left and on the right, the blue one and the orange one, and kind of make a list, notice the things about them that are different from each other. And so this graph on the left-hand side, I'm going to point some things out. I could just as easily here, I could draw something that we call kind of like a normal curve onto that. I could label it. Let's say this is age in years. Over here on the right-hand side, I would probably label this A, B, and C, and maybe these are groups of some kind. Maybe A, B, and C represents low, medium, and high happiness, or something like that. And so as we're going along, I'll introduce terminology. It's probably stuff that you already know, kind of either deep down or you just outright remember it. So please don't feel like that I'm patronizing you or anything. I'm just going to make sure that we're all on the same page in terms of the language that we're using. This graph here on the left-hand side is called a histogram. And some of the ways that you can tell that this is a histogram as opposed to something else is that the bars are touching. You'll notice that they come together here. And what that represents is that one, like let's say these are bins and they put all the people that are anywhere between 5 foot and 5'2", kind of like into this same bin. And likewise, like this is 5'4" and 5'6" and 5'8", 5'10", 5'0", 6'0", 6'2", 6'2". So they put them all into this bin kind of collectively together, but each one of these categories goes smoothly into the next one. There's not like a gap in between. There's not automatically a space. So these bars actually touch each other. And the fact that I drew this normal curve onto it also demonstrates that I think I am working with a scale variable that is continuous, a quantity of years that each person has. Oh, that's very bizarre. I put height on years. So ignore that. Math is harder than it seems. Okay, so on the right-hand side, over here you'll notice that I do have each of these different groups. I have group A, everybody in group B, everybody in group C, and the height, again, very similar over here. The height of this represents how many people are in this group, so this is some kind of count. Ew, I can spell. Okay, and the fact that this says something about groups really tells me that these are distinct from each other. This is actually called a bar graph. You see the bars. Histograms have bars too, but we don't call it a bar graph. And it's because these bars are separated from each other. These bars really just represent a continuum. If I happened to break this in a different place, my bars would be probably different heights, slightly, you know, the sum total would actually be the same. These are distinct groups. They're separate from each other. And so that's called a bar graph, and you'll notice that the bars are separated. And so a lot of times these two kinds of graphs are very confused with each other, a histogram and a bar graph. But a bar graph is used for categories or groups. So now that we've done that kind of really straightforward basic exercise, what I'd like to do is go back to the types of variables that we talked about in our previous lecture and really try to to summarize what kinds of graphs and summary statistics, descriptive statistics we would use for each type of variable. So let's give ourselves a little bit more space down here, and I'm going to recreate what we did before. Basically down here at the bottom, we have dichotomous, nominal, and ordinal with 7 or fewer categories. We have a middle group that has ordinal, we need that to be an O, 8 plus, and we have scale with not normally distributed. You're going to have to know that that's what that means. Just if I write it, that's not anything that other people use, but if I write NND, not normally distributed, I'll usually say it out loud so that you know that's what I mean. But that's on this particular graph, that means that it's skewed or kurtosis or some other way, it's just not normal. And then finally up here at the top we have just simple scale variables. So down here at the bottom, these are all categorical, categorical. And so what we're trying to do now is we are trying to come up with the best kind of graph and the best kind of descriptive statistics. In other words, graphs, pictures, and descriptive statistics, numbers, for each of these different kinds of variables. So let's go ahead and make this into a more of a table. There. All right, so we're going to fill in all the squares, basically. So for a scale variable, remember we talked about histograms, and so I'll draw ourselves a little histogram in here, and that's intended to be normally distributed. It may not be perfect, but it's relatively equal on both sides. There's even a section in your textbook that talks about how do I know if something's normally distributed. That's a great section to learn about that kind of thing, because we will be doing that later on in this quarter. So here I have my histogram for scale variables. For my dichotomous, nominal, and ordinal with 7 or fewer categories, very often I will make exactly what we have up here. I'll make myself a little bar graph. And there are a couple of interesting things about bar graphs. And these are not hard and fast rules, but they are just often followed. Bar graphs always do have the gaps. And so if you ever try to make a histogram out of one of these variables, it'll automatically in SPSS revert to this. But very often for dichotomous and nominal variables, we like to have this first category be the largest one. And the reason for that is then we can compare what the other categories later on follow. However, for ordinal variables, our brains are used to seeing things in order. So if we have something that's category 1, category 2, category 3, kind of a low, medium, high kind of situation, we almost always leave them in that order when we create the bar graph. So those are just some kinds of things to think about when you're creating bar graphs. I'll also introduce you, and you probably remember this from grade school, but if not, I'll just kind of remind you. This is a pie. You'll have to use your imagination. It could be any kind of apple pie, pecan pie, rhubarb pie. So here we have a pie. And a pie graph is also used for these categorical variables. And often here we have like different slices of the pie. And so we'll have like one group is here, next group, and so forth. So we have our different groups that represent slices of a pie. And often people will ask me, so when would I use a bar graph and when would I use a pie graph? It's not a hard and fast rule, but a pie graph is often used when we want to see percent of the whole. It's hard to tell how tall this is. Like, is that half of everybody, or 2/5 or whatever? Whereas over here in the pie graph, you can see that much more easily. Over here on the left, this is used more often if you want to compare 2 or more of the groups. So here we have groups 2 and 3 are kind of the same height, pretty close. But over here it would be very difficult to see if groups 1 and 2 were the same percentage, like which one is slightly taller than the other one. So if you want to compare the height of the groups, let me use another color. If you want to compare the height of the groups, then a bar graph might be better. But if you want to just see the percent of the total of the whole pie that each one is, then a pie might be a little bit better. So those are really common graphs, a bar graph and a pie graph. Now there's this middle section that is the scale variables but not normally distributed, or ordinal variables, and they've got lots of categories, so they kind of start acting, they got promoted, they start acting like a scale variable. So what kind of graph would we use there? And the name of the graph is called a box plot. And it's because what we do is we draw a box, and then we add all the other parts of that to the box. And so this particular box plot, it can also be called box and whiskers because it's a box with little whiskers sticking out. And the box plot can also have outliers and extreme values kind of out here beyond where the whisker extends. When we talk about the descriptive statistics, then some of the features about the graphs actually start making more sense. So let me go ahead and add some of that information here. When we draw a normal curve, this middle line is the mean, and I'll put that here. Mu stands for mean or average. And the thing that you notice about a histogram is it has this scale, often along the x-axis. Sometimes they tip it on its side and it's on the y-axis, but usually you'll see it on the x-axis. And that's your clue that you really have kind of this ruler. The mean is the calculated average, which, as you probably remember from grade school, you add up all the numbers and divide by n and you get the mean, or the average. And so this tells the location. Where is this curve located? Like it could be shifted to the left or the right, could be centered on a different number. This mean tells us where is the middle of that curve. And then the measure of spread is called standard deviation. And so deviation kind of sounds like what it is, like how far spread out, how far deviant are these other values from the middle number. And so mean and standard deviation are often the descriptive statistics that are used for scale variables. Now, soon, when we start working on your integrated project, you'll see why it's important for this to be normally distributed. In other words, the shape should be normal. In order for these features of describing that shape to really be accurate, it needs to be a normal shape. If it has a lot of skew, then these are not good descriptions of that shape anymore. So that's where we kind of drop down to this particular level. If we have a scale variable that's not normally distributed, or this fabulous ordinal variable that has lots of categories, then what we do instead is we look at the median. The median is the middle value, whereas up here, the mean is the geometric middle. In other words, we've added all the numbers up and divided by n. This is the physical middle of the data set. And the way this correlates with this box plot is the median is this middle number, is this middle line right here. The median is the middle person in the data set, and that's this line right there. Often we also report something called the interquartile range, IQR. You've learned about range. Range is the biggest number minus the smallest number. The interquartile range relates to this 75th percentile versus the 25th percentile. And so it's really how big is the box from here to here. And so this interquartile range really gives you information that's not really as biased by these outliers or the skew. It tells you how the middle 50% is spread out. And so standard deviation tells you how the histogram is spread out. Interquartile range tells you how the box is spread out. And then when we get down here to the bottom, for all of these categorical kinds of variables, dichotomous, nominal, ordinal with 7 or fewer categories, what we report on that is n and percent for each category. And so if you have 2 categories, you're going to have an n and a percent for both of them. Let's say that's male and female. If you have 5 categories, you're going to have an n and a percent for all 5 categories. So that summarizes the kinds of variables that we would use for descriptive statistics. Thank you for joining me.